In this lecture, we are going to be considering dielectric materials or dielectric substances, types of dielectric substances and their constants, what they mean by dielectric breakdown or electrical breakdown of a capacitor, dielectric strength and energy stored in the capacitor, and then we solve mathematical problems on energy stored in the capacitor. Let's get started. Dielectric substances and energy stored in the capacitor. Whenever we talk about the term dielectric substances, we are referring to insulating materials which are placed between the plates of a capacitor. So the insulating materials placed between the plates of a capacitor is simply referred to as a dielectric substance. We have different dielectric substances. We have so many of them as listed in the table below. So here you can see different materials, and those materials have their constants, and it also has dielectric strength as well. So the constants here for A, you can see 1.00059. For backlight, you see 4.9. So if we place, let's say, backlight in between the plates of a capacitor, it will increase the capacitance of that capacitor at this amount. Let's say we decide to use the dielectric substance like paper here. We place it in between the plates of the capacitor. It will increase the capacitance of the capacitor at this amount, 3.7. So that's the meaning of the constant here. Here you can see different values for the dielectric strength of different materials. For A here you see 3 times 10 to the power 6. For backlight, 24 times 10 to the power 6, and all of that. Okay, so the dielectric strength here, the insulator can withstand the voltage. You can see here, volt per meter. So this is the amount the insulating material can withstand, the amount of voltage or potential difference the insulating material can withstand per meter before breaking. I repeat, let's say I consider this material here, backlight. It has a dielectric strength of 24 times 10 to the power 6 volts per meter. That means that this insulating material can withstand a potential difference of 24 times 10 to the power 6 volts per meter when used in a capacitor. Okay, let's move forward. You can see figures of different capacitors. So here we have a tubular capacitor which consists of alternating metal foil and paper rolled into the cylinder. Also in this case, the dielectric material is paper and the capacitor is made in a cylindrical form. Here we have a high voltage capacitor consisting of many parallel plates separated by insulating oil. By my right here we have an electrolyte capacitor. So that's just a figure to show you different types of capacitors. You see this other one. Mostly we see this in electronic devices. Those are capacitors. Okay. Dielectric breakdown. Explain the concept of dielectric breakdown or electrical breakdown. A dielectric is a material that is ordinarily an insulator. We've talked about that. When it is placed between the electric field, when it is placed where the electric field is too high, when it is placed where the electric field is too high, the molecules will undergo partial ionization, which enables the material to conduct. So dielectric breakdown is thus said to occur when the field is large enough to cause the insulator to be conducting. We had talked about dielectric strength of an insulator. If a capacitor does not have an insulator between them, charges can flow from one plate to the other. Okay, so the essence of the insulating material is to prevent charges from flowing from one side of the plate to the other side of the plate. But there is an amount of voltage every insulating material can withstand before breaking. When it breaks, current or charges will now begin to flow between the plates as well. So dielectric breakdown is said to occur when the field is large enough to cause the insulating material to begin to conduct, whereby charges will flow from one plate of the capacitor to another. When it happens that way, we call it electrical breakdown or dielectric breakdown. It is a process that occurs when a dielectric or insulating material subjected to high voltage suddenly becomes a conductor, thereby conducting electricity. That's an additional definition to help us understand better. Let's take this one. It is a long reduction in the resistance of an electrical insulator when the voltage applied across it exceeds the breakdown voltage. What is the dielectric strength of a capacitor? Is the electrical strength of the insulating material. I made mention about that. Let's take this. In a sufficiently strong electric field, the insulating properties of an insulator breaks down, allowing the flow of charge. Dielectric strength is measured as the maximum voltage required to produce a dielectric breakdown through a material. So I said that the maximum voltage an insulating material can withstand per meter before current will begin to flow from one plate of a capacitor to another capacitor is simply referred to as the dielectric strength of the capacitor. This other definition says is the maximum electric field strength above which an insulating material begins to break down and conduct. Okay, so with this, I believe I've been able to give you different ways we can define the following electrical breakdown and then the electric strength of a capacitor. Energy stored in a capacitor. The energy stored in a capacitor is given by W equals to a half QV, equation 1. W equals to a half Q squared over C, equation 2. W equals to a half CV squared. Let's call this equation 3. These expressions can be derived as well. Okay, but in this lesson we are not looking at how they were derived, but we want to apply them in solving some mathematical problems. So these are energy stored in a capacitor. I would like my viewers to memorize these expressions perfectly. A half QV, a half Q squared over C, a half CV squared. So the Q here represents the charge, then the unit is in coulomb. The volt, V, represents the volts. C, or let me say potential difference for the volt, and C, capacitance of the capacitor in farad. Okay. Let's take this example. A capacitor of capacitance 5 microfarad is subjected to a potential difference of 500 volts across its terminal. Calculate the energy stored in the capacitor. Let me take it again. A capacitor of capacitance 5 microfarad is subjected to a potential difference of 500 volts across its terminal. Calculate the energy stored in the capacitor. So what we are going to do, we are going to pick one expression for the energy stored in the capacitor. But how do we know the one we are going to pick? We have to first highlight the quantities given to us in the equation. When we get it, when we pick an expression that will come with those quantities as well. So here we have capacitance of the capacitor to be 5 microfarad. Of course, you know the meaning of the term micro. This place is times 10 to the power minus 6. So whenever we are using it for calculation, we have to consider that as well. (500 volts). Which expression are we going to pick from equation 1, 2, or 3? Which one is suitable? Okay. So now we are going to substitute the values for C and then for V, and we square V according to the expression. When we simplify this, we will get 6.25 times 10 to the power minus 1 joules. Let's take the second example. This one says, estimate the amount of energy stored in a 5 microfarad capacitor when it is connected across a 120 volt potential difference. The quantities are almost the same as the other one, though the values are different. So I would like you to try this by yourself before I come in. Okay, let's continue. So we have the capacitance, the potential difference is given. We pick the same expression, we simplify it. So you compare your answer with the one we have here if it is the same. Example 3. This one says, estimate the amount of energy stored in a 5 picofarad capacitor when it is connected across a 120 volts potential difference. So you can see that here we are using picofarad. Of course, pico is times 10 to the power minus 12. Don't forget that. Capacitance is given. Potential difference is given. We pick the expression, simplify it, and we get our solution. Let's try the full example. This one says, estimate the amount of energy stored if the charge on the plate of a capacitor, if the charge on the plate is 35 picocoulomb and the capacitance of the capacitor is 1.5 picofarad. I take it again. Estimate the amount of energy stored if the charge on the plate is 35 picocoulomb and the capacitance of the capacitor is 1.5 picofarad. So we have to list the quantities. We have to find the energy. The charge has been given. The capacitance has been given. So we have to pick a suitable expression. Okay. Then we substitute the given values. And we obtain which value. I would like you to do that and then check what your answer would be. Okay. Thank you for watching Supreme Online Lectures. So you would see us both on YouTube and on Facebook. You encourage us by clicking on the subscribe button if you are watching for the first time. Like it and share. Thank you very much and have a wonderful day. Bye.